And what we're looking at right here is partitioning a directed line segment. And we're partitioning when it doesn't work out very nicely. We looked at some nice problems yesterday where we just can count over and see, oh, 1/6 of the way, that's just 3 spots. 1, 2, 3, done. Well, it doesn't always work out so nicely. And so what we're going to do right here, and this is broken down, it tells you all the steps. I've got both of these, both sides on one page. Hopefully it's big enough where you guys can follow along with what I'm doing. All right, so we're going to start by creating our own points. We're going to start with 8, -7, and we'll go with -5, 6. Actually, I don't want it to be -5. We can change that to -6. And it's going to be a 2-to-4 ratio. Okay, just get myself sorted out right there. So this step-by-step process, I want to make sure it's not just like, hey, do step 1, step 2, step 3. Now, in essence, that's what I'm going to tell you guys to do. But I want to make sure that that you guys understand why these are the steps. So the basic idea, well, let's start with plotting the points and drawing that directed line segment. So 8, -7 will put me right here. That's A. And -6. Sorry, I'm backwards there. 8, -7. All right. Is right there. Sorry about that. -6, 6 is going to be right here. Okay. And I'm going to connect this best I can. I actually have a tool I can make this work. So I have a straight line tool on my iPad. Okay, now just in essence, from the beginning, just so you understand what our goal is, we are going to be going from A to B. It's directed line segment AB. So starting at A, going to B, I want to go I want to split this in a 2-to-4 ratio. All right, so I want to find a spot that has about 2 partitions on the side closer to A and then 4 partitions on the side closer to B. That's really what I'm looking for. Now let's turn that into a fraction. So 2-to-4 is going to become what? 2/6. And what does that simplify to? 1/3. So if I imagine that I am walking on the graph from A to B, I want to find a spot that's 1/3 of the total distance. And that's where I will cut the line, okay? What you can do right now, and I encourage you to do this, guesstimate where you think that 1/3 point is. Just look at the line and you can visualize where about 1/3 of the way is. I'm going to guess about right there. Now, that's a little far, so I don't know, something in that range. It doesn't matter. You don't have to be right on. But going from A to B, that looks like about 1/3 of the distance. And the reason we do this, at the end, if we feel confident that we found about the 1/3 point, at the end, our coordinate should fall pretty close to where we guessed. And if it doesn't, then we did something wrong with our work. Or maybe you have a really hard time guessing where 1/3 of the way is. So that could be the other problem. All right. So there is the process here. So we're going to find this formally exactly where this point is going to be. And we're starting at A going to B. And we need to keep in mind if we're going a positive or negative direction. So that means from A over to B, I need to find my change in X. So I'm going to start at A, and I'm going to work my way to the left until I get to the same y value or x value as B. So I worked my way over, and now I'm kind of lined up with B. This is change in X. and we can count that up. What is it going to be? Well, and yeah, the one thing we have to keep in mind is if it's positive or negative. So what would we call this? Negative 14. All right. Then we're going to find our change in y. So from this point, I'll just continue counting. This looks a lot like slope, right? Whenever we find slope. And that's essentially what it is. What is our change in y going to be? Say that again? All right, and we're moving up in the y direction, so this will actually be, yeah, positive 13. And I'm going to write down the positive just so it's really clear that I am intentional about it being a positive movement. So we need to find those values. And I'll tell you, if you don't get your change in x and change in y correct at the beginning, if you don't get it correct, then you're not going to get the rest of it correct. And I try and do a good job with grading based on if you made a mistake at the beginning, not counting it wrong over and over, but, you know, it can happen. All right? And I don't want your mistakes to compound. So my change in x we determined is negative 14. My change in y, that's steps 3 and 4 that we're doing, is positive 13. We don't have to keep writing positive 13, but, you know, at least at the beginning, I want to make sure it's very clear. We have positive or negative possible. All right, so the next two steps, these are kind of paired steps. 3 and 4 go together. So I'll just kind of show that. These kind of go together. 5 and 6 kind of go together. And 7 and 8 kind of go together. And then we get to our final part there. So anything in 5 and 6 is going to be do this for the x value, now do it for the y value. So you can see what we're doing. It just literally says multiply your change in x by the fraction to get the run. Let's do the math real quick, and then let's kind of stop for a second, make sure we understand what we're doing and why. So my change in x is negative 14. The fraction is 1/3. So I just want to take those values and multiply them. So negative 14 times 1/3. And this is where you use your calculator. If you're not sure exactly what to do, just plug it in. Negative 14 times 1 divided by 3. Your calculator will do the work for you. So if you've got that, can someone tell me what that's going to be? Okay, negative 4.6 repeating. So what I'm going to do is I'm going to round it to 2 decimal places. Negative 4.67. And just standard protocol here, let's just round to 2 decimal places because a lot of times it'll be these decimals that go on for a long time. All right, and what we just found here, this is what we call the run. Now, we know about rise and run, and so we're using that language. I don't want you to think of it exactly the same way, but you can think of it more or less very similar. So negative 4.67 means if I was going to travel all the way from A to B, I'd have to go to the left in the x direction 14. I'd have to go negative 14. If I only want to go 1/3 of the way, I'm only going to go negative 4.67. And so that's kind of how you can think of what the value you just found. And don't go the full negative 14, only go negative 4.67.
And that will lead to that point right there, the negative 4.67, is that one dot?
Well, the one dot I put there is just a guess for now.
Okay.
All right, so we're going to do the same thing for y. My change in y is 13. My fraction is still 1/3. So now I can just do 13 times 1/3. And what is that value? All right, so 4.33. And you've got to have your calculator and be willing to do these calculations. So if you don't have your calculator, get it out. All right. All right, so again, just to interpret what's going on here, I don't want to go up 13 to get over to B. I want to get to my partition point, which is 1/3 of the way. So 1/3 of this total distance is 4.33. I don't want to go all the way to the left. I don't want to go all the way up. I only want to go 1/3 of each distance. So are these two steps making sense? All right, so now just to get the coordinate, because the final answer is a coordinate, all we have to do is take those values and add them to where we started from. So it's great if we're saying go negative 4.67, but now the question is, well, negative 4.67 from where? Well, from where we started. We started at A, and my initial A value is 8. So I'm going to take this 8, and this is where you have to pay attention. If it's directed line segment AB or BA, and go to the correct line segment, go to the correct coordinate, that is. But I'm going to take this initial x value, and I'm going to bring it down. So my initial x value is positive 8. And I'm going to add the run to it. My run is negative 4.67. And what did you guys get? 3.33. So what we just found here is what we call P sub x. I don't want the notation to scare you. All P sub x is the x value for point P. And you can see in step 9 where that P sub x is going to go. So we just found the x coordinate for our partition point. All right, and then in the same vein, I want to go up 4.33 in the y direction, but from where? I want to start at that initial y value. I'm not going to draw a line bringing it down, but the initial y value is negative 7. Everyone see that? All right, so if negative 7 is where I started from, and then I only went up 4.33, I can do that math, and that gives me what? Negative 2.67. Everyone agree? So this is P sub y. So when I put these into the coordinate, and you can see this is not something you're going to be able to do on the graph alone. You have to do the math, break this down. You're going to get 3.33, negative 2.67. Very strange coordinate, but let's see. And dang, I did a good job. My guess, and I changed the coordinate from first hour, so I didn't already know this could be. I just want to brag real quick how good I am. So anyways, over 3.3, down 2.67, and I put the dot pretty close to where it's supposed to be. So that's the reason for putting that dot, just kind of estimating. When I was guessing in first hour, I didn't get nearly as close. So, but anyways, you should be in the vicinity. So I encourage you guys to kind of estimate where your answer is going to be from the beginning. All right, so did that process make sense? All right,
Does
I'm
that
not.
find the slope for it?
No, we're not finding the. We can find slope, but we don't need it for
Then
this.
what's that number then? 3.3 then? Like, what's the
That's a coordinate.
What does that coordinate do then?
That's the coordinate. So we're splitting this directed line segment into a 2-to-4 ratio. And so if we're doing that, that tells us exactly where to put the coordinate so we split it perfectly. All right. So I'm not expecting you guys after going through this to be masters at it, but this does kind of break down the process and makes it as easy as we can make it. Now for the next one, I actually want to switch it around to, instead of directed line segment AB, so cross that out and change it to directed line segment BA. And let me see, what coordinates did I want to use for this? We're going to go with -7, -5 for A, and 9, 3 for B with a 3-to-2 ratio. If you feel like you can follow these steps, I have no problem if you want to kind of run through it on your own. And at the end, you can just check based on what we get. But I'm going to run through this process again, starting with plotting these points. And then, can anyone tell me what my fraction will be? 3/5. So 3 to 2 becomes 3/5. All right, and again, I'm going from B to A. I want to estimate where this 3/5 point is, and it looks like it's going to be close to the y-intercept. So that's just my random guess as to where P is going to end up. And just remember, with 3/5, it's not halfway, it's a little more than halfway. So you can just kind of, a very rough vicinity is all I'm looking for. All right, so now we can actually run through the steps. And just as a reminder, 3 and 4 kind of go together, 5 and 6, 7 and 8. All right, so let's kind of do both of these at the same time. It is B to A. So I have to start at B, work my way over to A. Okay. So there's my change in X. I'll just draw in the change in Y, but I'll count it up in a second. There's the change in Y. And what is my change in X going to be? Negative 16. Change in Y is negative 8. All right, is everyone good with those two?
Yeah, but how did you get the fraction 3/5?
That's where you convert the 3 to 2 ratio.
3 plus 2.
Yeah, and yeah, that's what we did yesterday, so if you need to watch that video. Okay, let me just write those down. We got negative 16 and negative 8. All right, so again, now it's kind of just run through the calculations. Negative 16 is my change in X. And then times 3/5. So, what is negative 16 times 3/5? Say that again? Negative 9.6, thanks. This is the run. Do the next calculation. We've got change in Y is negative 8. You don't have to copy down the change in Y like I'm doing. I'm just trying to make it very, very clear what I'm doing for all these steps. If all you want to show me in your work is, this calculation right here, the negative 16 times 3/5, I'll be able to follow along. All right, so now I'm going to do the negative 8 times 3/5, which gives me what? What was the first number? Negative 4.8, thank you. All right, the rise and the run. Again, to interpret what rise and run means in this context, when I'm going from B to A and I'm trying to find a 3/5 partition point, I don't want to go the entire length. I want to go 3/5 of it. So that just told me how far to go for my X and how far to go for my Y. And that'll get me to my partition point. So the last step is how far, we know how far, but from where? Well, from our starting point. So I'll take my starting X value, which is what? 9, yeah. So the starting one is my B X value. So 9 plus, and we're adding it. So it's going to be plus the negative 9.6. You should be able to do that in your head. What's that going to be? There you go. Just negative 0.6. And when I say you should be able to do that in your head, plug it in the calculator. Make sure. Don't feel like you have to do this stuff in your head. So this is the P sub X, which is the X coordinate for the partition point. I moved over negative 9.6 from the starting value of 9, and that told me where the partition point is going to end up in the X direction. All right, the Y coordinate that I started at was Yeah, okay, I heard someone say 3. And now I'm adding the rise. I got to get myself right. 3 plus negative 4.8. That's the rise right there. What does that give me? Negative 1.8. And this is P sub y. All right. So I'll tell you on the quiz, let's say you mess up and something went wrong along the way and you did not get these values. But you did calculations, you came up with an answer. Part of your test is going to be what's your final coordinate. Show me all your work to get P sub x, all your work to get P sub y, and then show me your final coordinate. As long as you take whatever you get for P sub x and P sub y and plug it into your coordinate at the end, that's some partial credit. Okay? So you might be wrong on P sub x, but as long as you plug it into the coordinate correctly, then it's worth something. So anyways, this is the easy part, I guess I might say. So negative 0.6 is your P sub x, your x value. Negative 1.8 is P sub y, your y value. And we can see how close we came. My actual partition point is about right here. So that's how close we got. If you can see that. All right, so this handout is going to be the most essential thing for you to be kind of looking at, having available for the next few days while you practice with this. We have some time in class. We're going to go through one more of them where we don't have this broken down step by step. So I'm going to show you kind of in practice what this might look like on your test or as you work. All right, are there any questions on this though? Okay. So the handout from yesterday, you can get that out again. And I'm going to look at either one of number 7 or 8. It doesn't really matter which one we do. Does anyone have a preference? Okay, I heard 7. All right, let's do problem 7. All right, now it doesn't tell us step 1, 2, 3, 4, 5, all through 9. So we just kind of need to reference that other page. And I'm going to go ahead and plot the points. Negative 5, 5. It's right here, and that was what? G. 8, negative 9 is H. And I will connect them together. There we are. So you guys have your reference page sitting right next to you, hopefully, and I'm not going to see it up on the board, but you guys can kind of follow along with the steps. So what's the next thing that we do? Yeah, we want to change this ratio to a fraction. So remember, and for those of you who were not here yesterday, the way that we do this is, I'll just write it out again. If your ratio is A to B, then your conversion is going to be A over A plus B. Just take the first number and put it over the sum of both numbers. So what's it going to be here? Okay, 8 over 18. So it's just 8 over 8 plus 10. What can that simplify to? What does 8 over 18 simplify to? 4 over 9. All right, so there's the fraction. So 4/9 is not like immediately obvious. We just think it's not quite halfway. That would be, 4.5 over 9. It's close to halfway. So go ahead and on your own, guess where you think that point is going to end up on your line. So I guess somewhere right there. We don't want to take a long time on that. And we're going from G to H. So now here's what I do is if I have this room to work with, I want to kind of split it into my X and my Y. So I want to have my change in X over here and my change in Y. And then remember from there we're going to get our run and our P sub X. Now you don't have to have this written out all from the beginning. Maybe I shouldn't have written it out yet, but we'll see it eventually anyway. So let's say we're going to solve for all these things on the left and then on the right. So my change in X, if I'm going from G to H, what's my change in X going to be? All right, you said 15? Oh, 13, I'm sorry. So my change in X right here is going to be positive 13. All right, that looks good to me. Now this is where you kind of get to your own personal preference. You can actually run through and just do all of the X stuff right from the beginning. You've got your change in X. You can figure out your run. You can figure out your P sub X right now. I think just for consistency, I'll do the X and Y at the same time. So what's my change in Y going to be? Negative 14. Okay. So on your paper, it tells you how to find the run. What do we do? There you go. Take that 13. We don't want to go the full 13. We only want to go 4/9 of it. So 13 times 4/9 gives us there you go, 5.78. So if you're doing this calculation and you see it on your calculator, you're seeing 5.7 repeating. So since we're rounding to 2 decimals, that was good rounding there, Logan. So we'll want to round it to 5.78 and just call it good. Okay, let's get the rise. Same sort of thing. So tell me the calculation on that one. Okay, well, what we do to get the answer. Okay, so it's negative 14. Make sure you know it's a negative 14 times our fraction, 4/9. And you can go ahead and tell me the number. Negative 6 point, and that's 2 repeating, so just to be really thorough, we'll do negative 6.22. Okay, so now we can find our actual X and Y coordinates. So P sub X is going to be, what do we do to find P sub X? What are we adding? There you go. Add that run to the initial X. The initial X is negative 5. And I'll just show this right here. We're starting at G, so that's why I'm pulling that X value in. And then I multiply that, or sorry, I add that to the run. And that gives me a P sub X of any takers? Yeah, there you go, 0.78. If you just write 0.78, I'm fine with that. I like to write the 0 in front of it. All right, so P sub Y. We're going to take what value first? There you go. I'll take that initial Y value. And that's going to be 5. I'm going to add what to it? We'll add the rise, so negative 6.22. And that gives me a P sub Y of, there it is, negative 1.22. So that helps to kind of organize the work, how we did this here. And my final coordinate, I'll just write it. I thought I'd give myself a little more room, but I kind of ran out. But anyways, 0.78, negative 1.22. There's the final answer. I know, hopefully it's big enough you can read that right there, but just plug your x and y value in. And double check against where you put the point. See if you did well. And it looks like I came pretty close, so I'll just call it good. All right. So I'm not expecting you guys to take a quiz on this on Monday. But if I did have you do a quiz on Monday, how confident do you think you'd be able to do pretty well? So just give me a 1 to 5 real quick. Okay. Now the good thing is, and that's good. I'm happy to see where you guys are at. So you are going to have more practice. You will have a quiz on just this next week. I'm not going to add more to it, but I want you to just get exposed to it a little bit more. Anyways, you will have a quiz, and then, anyways, yeah. Go from there.